Hi everyone, my name is Avinash. Welcome to my YouTube channel. In this video, we have discussed how we can build and deliver a three-tier architecture application by using AWS own services. See, before starting this project, you should have some experience with AWS services like EC2, IAM, Route 53, Autoscaling group, load balancers and RDS. So by combining all this along with VPC, we have built this architecture and we have delivered a three-tier architecture. One thing, whenever you're doing this for the first time, so definitely it is going to looks like a complex topic, but if you're going through multiple times, so definitely you can understand what we are discussing here. Without any further delay, let's jump in and let's start building our three-tier architecture on AWS. And don't forget to subscribe if you found this video helpful. Alright, so first of all, what exactly this three-tier architecture is? Three-tier architecture is a common best practice for developing and delivering our application. See, in this three-tier architecture, technically we are going to have three layers or tiers. Okay, so first one is web layer. So web also referred as a presentation layer. See, this is like a UI, user interface. Okay, for example, if you are taking an application, so when you open that application, how it looks like, the look and feel comes under this web layer. So we can generally use this HTML, CSS for this web servers. And then second layer is application layer. Let me take a simple application to understand this three-tier architecture. So that application is a small kind of inventory application. Let's assume we are dealing with an inventory application where we are going to have a front web page, and to manage logics we are going to have app layer or logic layer, and the actual data stores in backend database layer. So now as a user, what I want to verify, as it is an inventory application, I want to go to this front web page. I want to search a particular item availability. Whenever you go to any store, if you ask, for example, nowadays if you go to medical store also, if you ask them for a medicine, first they are going to check in that application whether that item is available or not. So they are going to verify here in this presentation layer or web layer. They will enter the required information here. So now this is actual database, like we have relational databases like MySQL, MS SQL, PostgreSQL, Oracle database, right? So the entire data is going to store here. So whatever the item we are searching here, it will go to this logic tier or layer. So it has algorithms, or it has the code to go and check in this backend database where actual data is present. Okay, so in simple, most of the times this logic or app tier written in .NET or Python or Ruby language or Node.js, right? So it written in this programming language. So that actually runs this layer. Now this all data actually stores in this database layer. So it is a very standard practice, delivering applications in this three-tier architecture method. Okay, so now what actually I'm going to perform? See, I'm going to take a web tier that is going to deliver a front-end website, and I'm going to take an application tier. It is going to take API calls and it is going to handle the business logic, and database tier, it is going to manage data stores and data retrieves. Okay, so first, whenever we are using this, I'm also going to use components like application load balancer. So the reason, in this logic or app tier, we definitely don't depend on only one EC2 instance or one server, right? We might have multiple servers here. We definitely might have multiple servers here. So to provide single point of contact for this application tier, and this presentation tier, I'm going to use load balancers as well. For this presentation tier, I'm going to create a public facing application load balancer. So then I'm going to create web tier. So that is nothing but I'm going to launch an EC2 instance. I'm going to install Nginx, and also going to run a small React.js website. So the front end is going to delivered by Nginx only. So it is going to provide the interface, it is going to take the API call and it process the API call. So from this web tier or from this web EC2 instance, where the calls will go, it goes to this application tier. But again, we might have multiple application tier instances, right? So I'm going to use an internal load balancer here. So you might get a doubt, okay, why we need internal load balancer for this application tier? Why we need public load balancer for this web tier? So web is intended to delivered for public users. Everyone should able to access it. But this app, right, I don't want anyone directly to access this app servers. This app server should have communication to only web tier, and it is responsible to connect to database and running the logic and providing outputs to this web tier. So all are going to be in same VPC. For high security purpose, I am not going to create a internet facing web server, load balancer. I am going to create an internal load balancer. Alright, so that is the reason why I have selected internal load balancer. So then the EC2 instance which handles the load, it connects to the MySQL. Okay, so then database tier. So in this database tier, right, we are going to have a database, and we can use that to store the data. And also this database, for high availability purpose, we can enable multi-AZ concept. Okay, so that gives high availability and fault tolerance for our database we are going to create. Right, along with that, on this load balancer, we are going to configure health check. We are going to perform auto scaling group also. So for example, so this application, this web is getting more traffic, whatever 2 servers we have currently, it's not able to handle the load. So then based on the load, I want to add one more server. So not only this presentation or web layer, even at app layer also, I want to have multiple servers and I want to scale that based on the load. So for that, we are going to implement auto scaling group. So then I'm going to enable secured, I'm not just going to use HTTP, I'm going to use HTTPS protocol, so that I can map my domain name and I can redirect to HTTPS. So this is a domain name I'm going to use for this specific video. Alright, so this is what exactly theoretical introduction to our AWS 3-tier architecture. Okay, let's go to implementation steps. This is what I'm going to implement now. So the step 1, or you can take it as a phase by phase. Phase 1, prepare VPC. So first phase should be prepare VPC. Why? Because in real environments, we don't depend on default VPC. We always go with the custom VPC only. So within this VPC, what actually we are going to do, we are going to take 2 availability zone, AZ1 and AZ2. Right? We are going to create total 6 subnets. Out of that 6 subnets, 4 private subnets. These 4 are private subnets. This web tier is going to run in public subnet. I am also going to take a NAT instance also. The reason I want to provide internet to this app tier EC2 instances which is running in private subnet. If you want to provide internet to a private subnet EC2 instance, you should have NAT gateway. Earlier we used to have NAT instance, AWS stopped supporting it. So we should create a NAT gateway. So if you already have experience with this VPC creation, you can use this wizard. So currently I'm going to work on this Mumbai region. So navigate to Mumbai region, click on create VPC. You can select VPC and more here so that you can create VPC very easily. If you don't know how to create this VPC, if you don't know what exactly these private subnets, public subnets, I recommend you to go through our VPC video available in our YouTube channel, and I will also place that in our um, video description. So here I have explained in these 3 videos, I have explained so what exactly VPC, how to create the VPC, what exactly this NAT gateway and all I have explained in this video. I strongly recommend you to go through that video. So one thing, before starting this project implementation, I am assuming you know what exactly VPC is. You know how to launch an EC2 instance and connect to it. You know how to create and configure a load balancer. I'm assuming you know how to create and configure Autoscaling group, and how to create a database and how to get connected to it, and how to create an SSL certificate. I'm going to create all these resources, but I strongly recommend you first learn all these components manually, so then you implement this project. Alright, so now I'm going with VPC and more, and the name I'm going to give auto generated, or you can simply start entering the name here. What is the name you want to give for your VPC? What is the name you want to give for your public subnet? What name you want to give for private subnets? You can give that here. So I'm going with auto generated, but I will just modify couple of things once this VPC got created. I'm going to use 192.168.0.0 slash 22 as my VPC CIDR. I have to give name here, 3-tier project, 3-tier hyphen project is going to be my VPC name. So the subnets, VPC name subnets are going to have this as a prefix. Alright, I'm going to take 192.168.0.0 slash 22, and now how many availability zones you want to span this across? 2 availability zones. I'm taking AZ1A, 1B. And why we need to span this or spread these resources across multiple availability zones? See, you have an EC2 instance, and that EC2 instance running only in AP South 1. Okay, so if something happened to this availability zone, any operational issues occurred, your application will be down, right? So it's always recommended to span your resources across multiple availability zone. So I'm selecting at least 2 availability zones, and those are going to be AP South 1A and 1B. So then how many public subnets you required? I need 2 public subnets to run this web tier. You can observe here, to run this web tier, I am going to take 2 public subnets. How many private subnets? I am taking 4. Okay, why we are taking 4 subnets? For app, 2 subnets, for DB, 2 subnets. One is for 1A, another one is for 1B. For a database tier also, one for 1A, another one for 1B. Alright, so now do you need NAT gateway? As I told you, whatever the resource running inside this private subnet, that definitely need internet. Why? Because I'm going to download and I'm going to install some package. I'm going to use this React.js package, download and install. So for that, definitely we need internet for this private subnet instances. So I'm going to choose NAT gateway, but one NAT gateway is sufficient. And VPC endpoint, if you want to provide S3 bucket access to this private subnet EC2 instances without NAT, without internet, then you can go with S3 gateway endpoint. But the thing is, I'm creating NAT, right? I no need to create any VPC endpoint. By using NAT also, we can access that S3 buckets. Then click on create VPC. So VPC creation won't take much time. It hardly takes around 4 to 5 minutes. Then it's going to be ready. So take this as a phase 1. As I told you, let me write that in this document. So phase 1 or step 1, create a VPC for your project. Phase 2, create an S3 bucket and upload your code. So then create an IAM role to attach to EC2 instance. So then phase 3 is going to be create an RDS database. Phase 4, create application tier resources including internal load balancer. Phase 5, create web tier resources including external load balancer. Phase 6 is going to be generate an SSL certificate and apply it to external load balancer and map external load balancer, map domain name to external load balancer. So these are the phases we are going to perform in this video. Alright, so now we have to create an S3 bucket. So basically the required code I already created and it's in my GitHub repository. So here is a GitHub repository. It's a public repository. You can easily clone this to your local laptops. All you need to do is you just get the repository URL and clone it. So I also observe here implementation steps.md is a document I have added here. Click on that. So now if you scroll down, first clone this repository to your local laptop. First, okay, so now I'm in my local laptop. On my desktop, I'm creating a folder YT3 tier project. So now I'm going to, I already have Git installed in my laptop. I'm simply cloning it. So now all the code is inside this. Okay. So this is actual code. Okay. So this you can ignore these things. You can go to application code. So primarily you have to edit two files in this. One is under app tier we have dbconfig.js. This you need to edit and you have to replace this information with your database information. That is the first thing. And second thing, this nginx.conf we are going to use at web layer, and here once you complete this application tier with the internal load balancer, you have to pick this internal load balancer DNS name and you have to replace that here. These are the two modifications you have to perform whenever you are using the code I have provided here. Okay, I have taken this code from AWS workshop and I have modified it accordingly. So that code don't support HTTP to HTTPS redirection and all. I have performed appropriate modifications to that code and I made it available. Alright, so now first what we need an S3 bucket to place all this code. Why? Because see, copying all these files to our EC2 instance, these all small files to our EC2 instance is obviously a big task. So what I'm going to do, to copy all this data to my EC2 instance, I'm going to use this S3 bucket help. If you want to directly clone this repository into your web servers and application server, you are good to do that, but I recommend this process. Okay, my bucket, I'm creating it in Mumbai region. I'm calling it as a YT3 tire project as a bucket name. Create bucket. Hope that bucket name is available. It got created. Alright, so now as a next thing, I'm going to upload this entire application code here. I'm uploading all this application code. So this S3 bucket we will use after some time. Again, as I mentioned, you have to edit this nginx.conf as well as apptiredb config. Once our database is ready, we need to edit this. Then after we will use this. Okay. Now, so we need to create an IAM role. So why we need to create an IAM role? See, we have an EC2 instance and database in private subnets. How we can get connected to those resources? Either you have to create a Bastion host here. So Bastion host or jump server, you have to launch it here. Then you can get connected to it. But instead of that, we have an option called Systems Manager, SSM. So we can directly, if we attach appropriate role to this EC2 instance, even though if it is in private subnet without any public IP address, we can get connected to it by using SSM agent. So, but how SSM can connect to these EC2 instances? With the help of a role. So now go to IAM screen, create a role that we are going to attach to our web server as well as application server. Navigate to roles, create role, use case, I'm going to attach this to my EC2 instance, then click on next, search for SSM. Whenever you search for SSM, you can observe this Amazon EC2 role for SSM. If you attach this, we can connect to this instance. Not only just connectivity, we can also access S3 bucket objects also. So whatever the data I have placed here, the code, that also we can access by using this role only. So click on next, give a valid name, YT-3 tire project is the name I have given, then create role. So we are good with this phase 2 also. Alright, so now let's create an RDS database, and but before creating an RDS database, our VPC is ready. Okay, we have these all subnets, but question is, see, we have 4 private subnets. Among these 4 private subnets, which one we are going to use for database, which one we are going to use for application, that we have to segregate. These 2 public, yes, we are going to use it for web layer. But now what I am going to use, I am going to rename this private 1 and private 2 for app, private 3 and private 4 for database for our easy understanding purpose. So let's go here, edit, instead of this private, I am going to call this as a app 1. So then private 2, I am calling it as a app 2. One is in 1A, another one is in 1B. So we are good with that part also. And I am taking this private 3 as a DB1 and private 4 as a DB2. Alright, so now whatever database I am going to launch, that database should run among these 2 subnets only. So how we can, whenever we are creating a database, we don't have any option to choose the subnet. So then how I can ask my database to run within the subnets only? So for that we have an option called subnet group. Navigate to RDS, here Amazon RDS, navigate to subnet groups here, then create a subnet group. If you already have any, see I already tested couple of things, so it is actually empty. I deleted that. Now let's create a DB subnet group. Create DB subnet group. You give a name. So 3-tier subnet group is a name I have given. So you can give same as a description, but it is mandatory. Choose the VPC. I have selected my 3-tier project VPC. Now, what are all the availability zones? 1A and 1B. Now it will show you all the subnets we have in 1A and 1B. Sometime back we have renamed this one, right? So DB1 is ending with 62 and DB2 ending with 7A. So let's select that. One is 62 and second one is 7A. One is 62, second one is 7A. So now these two subnets, when I am launching any database, if I selected this specific subnet group, my database 100% run within this subnets only. Okay, it won't run in any of other subnets like app or public subnets. Then create. Invalid subnet group name, it's not supporting character as a, I mean the first letter as a number, it's not supporting. All right, so now tier subnet group is the name we have given, so we are good with the subnet group creation part. Create DB subnet group, and now create an RDS database. So for this demo I'm going to pick MySQL database. And also if you really want to enable high availability for this, optionally you can enable multi-AZ. So when coming to cost perspective, here NAT gateway will cost us. This S3 bucket and role is absolutely free. S3 bucket you should be within free tier limitation. And this database, so you can choose MySQL database with the db.t3 micro or db.t4g micro is coming under free tier eligibility. So if you want to be within free tier eligibility, you can skip this multi-AZ configuration part. I personally recommend that. So now let's go to database, create database. Now I'm going to choose MySQL. If you want to utilize Amazon Aurora's advantages, you can go and choose Aurora as well. But this MySQL, right, it has free tier option. So that's the reason I'm selecting MySQL. If you selecting this Aurora, you observe here there is no free tier available. So select MySQL only, then scroll down, select the engine version. We always go with the N-1 or 2 versions. Now select free tier. If you are looking for high availability, as per this diagram, if you observe this diagram, we have one primary copy here, we have a replica copy here. So if you are enabling read replica or multi-AZ mechanism, you will get another copy of your database in another availability zone. So if you really want that, you can select dev test environment, you can choose multi-AZ DB instance. The cost is going to be double. You see here, cost is going to be double. So if you enable that, so as I told you, I am trying to be within free tier limitation as much as I can. So I am selecting free tier. So then what is the name you want to give? My YT project DB is the name I have given. So then what is a master username? Admin. Credentials, I'm going to use self-managed credentials. So that means this is going to be username, and here I'm going to enter the passcode. If you want to use services like a secrets manager, you can even use secrets manager. That video also available in our YouTube channel. You can go through that if you really want to. So now I'm going to give a password. The password I'm going to give somewhat neutral password. However, I'm going to reveal that password. My DB username is admin. DB password is Avinash12345. Okay, we are going to use this after some time. So now you can choose T3 micro or T4G micro. This T4G is a graviton processor. So it also comes under free tier eligibility. You can choose the T4G micro if you want to be within free tier limitation. And storage type, we are good with GP2. 20 GB is fine. Storage auto scaling, not really required. And I'm going with don't connect to my EC2 instance. I'm going to deal with this security groups manually. Now we have one more step here. Okay, create security group for your resources. How many security groups you required? So one for web servers, one for web application load balancer, one for app servers, one for app internal load balancer, one for database we have to create. So we need these many security groups. So first let me create this database security group. Okay, so now let's go to EC2 screen again. Here you can observe security groups, create security group. I'm going to call this security group as a RDS security group, database security group. Choose the VPC where you want to create and inbound rules. So basically we are launching MySQL. MySQL actually runs on port number 3306. So you can go and open that MySQL port number here. But to where you want to open? Okay. So it is not at all recommended to open for anywhere. It is not recommended also. So, but for time being, what I'm going to do, I'm going to open for this our entire VPC CIDR range. Okay, we can modify it, we can implement VPC CIDR. So whatever the resources running within this VPC, only those resources can communicate with my database. So we have another mechanism called pipeline mechanism. We can give simply security group of our application servers. So that we will add later, then create security group. Now this security group I'm going to attach to the server or instance, DB instance I'm launching. Don't connect EC2 instance. I'm going to select the VPC I created, 3-tier project VPC. DB subnet group, this is important to select. Public access, absolutely no. My database is going to contain lot of sensitive information. I am not ready to make it public access, and I also want to run this database in a private subnet. So I'm not going to make it as a yes, this option. I'm going to set it to no. And security group, the one we created, RDS SG, I'm selecting that here. Availability zone, you can choose 1A or 1B, and remaining all options we can go with default option. Port number 3306, we are going with password authentication. If you want to enable enhanced monitoring, and also if you want to give any initial database backup, it's highly recommended to enable at enterprise level. But now, for now, you can uncheck this, so the process will speed up. Encryption also purely your choice. Auto miner version upgrade not really required. Then scroll down, create database. So this database is going to create in some time. So it's hardly take like 5 minutes. Within 5 minutes, this database is going to be ready. We will take that database information, we will update the configuration and we will upload that to our S3 bucket. This, as I mentioned, this is going to take some time, right? Meanwhile, let's prepare this security groups. Okay, we created one security group for database. Let's create one for application servers. Let's create one more for web servers. So let's go to security group screen, create security group. So first I'm going to create web application load balancer security group. So basically this security group I'm going to attach to the load balancer I'm going to run on top of web tier. So everyone should able to access this. So I'm going to open HTTP for anywhere, also HTTPS also anywhere from the world. Why? Because I'm going to use HTTPS protocol later. So that is the reason I'm opening HTTPS as well. Then create security group. So this web internet facing application load balancer security group got created and web server security group required. So go here, create. I'm going to call this as a web SG, giving same as a description. Select the appropriate VPC and here I'm going to open HTTP traffic. I'm not opening for everyone. See, we have this pipeline mechanism. We can simply give security group of my web application load balancer. This is more secured option, piping to elastic load balancer. Otherwise, if you don't understand what actually I'm doing here, what you can do, you can add a rule, open HTTP, give your entire VPC CIDR range. So let me copy this. So you can always, instead of opening it for everyone, you can give your entire VPC CIDR range, then create security group. So we have created one security group for web servers, and these two completed, web server and web internet facing completed. Now one application server, one application internal load balancer security groups are pending. So basically this application is going to run on port number 4000. Okay, whatever the React.js application we are going to use, it actually runs on port number 4000. So I'm giving app SG. App SG is a description. I have given the VPC ID. Add role, I'm going to use custom TCP. I'm opening 4000, and again, if you know the pipeline mechanism, you can use it. Otherwise, you open it for entire VPC CIDR range. Then create security group. Also one more. So now create a security group for our internal load balancer. Create security group. Internal application load balancer. You can give same as a description, security group, inbound roles, and here I'm going to open to port number 80. So that is nothing but HTTP, and again I'm opening it for my entire VPC CIDR range. I know whenever you are doing this for the first time, right? So definitely it looks bit complex. So you have to watch this video multiple times. You have to go through it multiple times. So then only you can understand the concept very clear. So you can do one thing. You can create one security group. You can open all traffic for everyone and you can use that for all the resources you are creating. But that is not at all enterprise level standard one. For every resource, we prefer to create a dedicated security group and we use pipeline mechanism. If you observe among all the security groups, only this web application layer security group is open for everyone. So that means only this load balancer is internet facing. Remaining all the resources, I am not preferring to run it as an internet facing one. So that's the reason this load balancer not open for everyone, database not for everyone, app servers not for everyone. Okay, so that is the reason I followed and I created these many security groups. Alright, let's verify whether the database created or not. So the database created. Now our database is ready. Let's get this database information, and as I told you, we have to copy this endpoint information and this username and password, right? So these information we have to update here under app tier. So why? Because our application servers, what are the application server we are going to create now, that should be able to connect to our database. For that connectivity, it is going to use this user's credentials. So you can create a less privileged user and you can configure that, but for this demo purpose I am using this admin user itself. So let's open this dbconfig file by using your own editors. Right, I am using Visual Studio here, and this part need to be replaced. Okay, let me choose this. Okay, username is admin, password is Avinash 12345. Database name we are going to give as a web app DB. Okay, we have to create that. I haven't created. So, but as database is ready, I prepared this file. So now what we need to do? This dbconfig.js need to update in our S3 bucket. Under application code, app tier, this dbconfig.js need to be updated. Alright, I have updated. We are good with this dbconfig part. So now we have to launch an EC2 instance. See, at a time I am not going to launch two EC2 instances. I am going to launch only one instance. Okay, so then I am going to do all configurations like a connectivity to this database, creating the database, creating a sample transactions and all, everything I am going to perform here. Okay, so now again let's go to EC2 screen, launch an EC2 instance, launch instance, and this is going to be my app tier instance. I'm going to choose Amazon Linux 2 AMI. I'm going with T2 micro, that is the one comes under free tier eligibility. I'm going to select an existing key pair, and VPC, you can choose the newly created VPC, and subnet specifically. This is our app server. So we have to launch within app subnet only. So click here, read it, and once you find this app 1, app 2 subnets, right, I'm going to launch it in app 1 subnet, select it. Public IP address not required, it is a private subnet. Security group, we already created subnets for this app. I'm selecting that app subnet here. Okay, this is internal ALB. For application servers, we have selected app SG. So the important thing is 4000 need to be opened. That's an important thing. So now 8 GB GP2 is fine, and whatever the role we created, this role YT 3-tier project is our role name. This role need to be attached to our EC2 instance. Otherwise, you cannot get connected to this instance. Then click on launch instance. This instance is going to launch now. Let's get connected to this instance once it is launched, once it is up and running. So now within this instance, what I am going to do? So if you observe this implementation steps, I'm going to install MySQL. You can observe here within app server. This is app server setup. If you scroll down to bottom, you can see web server setup. So first I'm going to install MySQL client. See, I'm just giving yum install MySQL. That is not MySQL server. It is MySQL client. So you gave MySQL client. First install MySQL client. Then connect to your database. The one we already created here. This one. So once you got connected, create a database. So then show database, this should display. Then we are going to use it. Then we are going to create a table. Then we can verify that table creation by running show tables, and we can insert this sample information. Then we can run the select star from transactions. It should show this information there. So once that is completed, so then we have to update this dbconfig file, just we already did some time back. Now we have to install this react.js and pm2. Okay, so for that we are going to use a small script. So then we are going to install nvm. We are going to install pm2 to run it continuously as a service, and then these are some pm commands. So we are going to run this index.js by using pm2. Then we are just verifying things here. We are verifying the configuration by running this command. So you should get output like this. Okay, again, if you don't know what is this pm2, how to install these things, we do have a dedicated video how to run a Node.js application inside an EC2 instance in our YouTube channel. You can refer that, but for now you can go through these small scripts. So now instance should be ready by this time. Let's get connected to it. So you cannot SSH into it. Why? Because it's running in a private subnet. Directly you cannot SSH. So that's the reason I'm going to click on connect. Then I'm using this session manager. Then click on connect. So if you don't attach role, this session manager feature won't work. If it is not working, then problem with the IAM role you attach it to this instance. Verify that. Then click on connect. Okay, so now we got connected to this instance. I'm giving sudo space su. I got connected to root user. You can even run who am I. I'm going to this slash root path. So basically I prefer to work in this home of EC2 user. Give ls and pwd. Alright, now I am able to connect to this private subnet EC2 instance. Now next what I need to do. So we have to install this MySQL. Install MySQL. I will just move that here next to tabs. Right, it got installed. Now let's get connected to it. So you have to replace this name with your actual database name. So sometime back we prepared this information here, right? So now this is what our DB endpoint. Replace that here. So then copy it. Whenever you are pasting it, it should prompt for a password and enter the password. In my case, if it is it's Avinash12345 and we got connected to this MySQL. If it is not connecting, the problem is with the security group of your database. Verify your database security group. Now, as we discussed, we have to create a database, we have to create a table, we have to verify whether entries are really like copying there or not. So you can simply run this first command. Right, it got created. So then you can run the show databases. It should show database. It got created. You see here, web app DB got created automatically. So these performance schema, information schema comes defaultly. You no need to worry about that. Okay, I did a mistake. Let me connect to this MySQL again. Okay, so now what we need to do, we have to use this web app DB here. Okay, database now got changed to web app. Earlier it is none. Whenever you gave use web app DB, it got changed. We are actually using the database. So we are creating a table within the database. A table name is going to be transactions. So paste it. Table got created. Now how to verify whether table got created or not? You can run simply show tables. It should show one table that is with name called transactions. So then you can insert some information. Okay, this is a command. It is going to insert value as a 400 and description as a groceries. If you have different thing, you can give that as well. So now 400 instead of groceries, I am giving my name Avinash. Alright, so that got executed. Now you can verify whether the entry really created or not inside the database. You can run this, select star from transactions. You see here, whatever the query we ran, this insert into transactions query, it executed the information actually stored in the database table. So that means, in simple, to conclude this, from my application server, I am able to get connected to my database server. I am able to write some information there. Okay, so the connectivity part and initial DB setup part is completed. So if you observe this diagram, so the connectivity is there between this two resources, this resource and this resource. So this database connectivity not really required for web tier. It should be available for application tier only. Okay, now enter exit. So we got disconnected from the database. Now, so this application tier is the heart of this 3-tier architecture. It is the one who is going to look for the logic. It is the one who is going to fetch the data from database. So to fetch the database, we should install some things. So like this npm and all, nvm and all. Okay, so you just copy this, paste it, automatically a script is going to download. So the script got downloaded. Now go to this, you are just initializing that as terminal, and now install this nvm install 16. So once this installation completed, we can use this nvm use 16. So basically this nvm stands for node version manager. So we are using node version 16.20. So technically that is node package manager version 8. Okay, so now we are installing something called PM2 to run this node as a service. Otherwise it's going to run in interactive method only. So you have to leave this console in this just like an interactive method. So otherwise you cannot run it. Okay, so now that PM2 installation also completed. So now whatever the code we have, we need, so that code you need to get it to this app server. So you remember we already copied that code to this S3 bucket. Now that code need to copy to this app server. So for that you can take this again, this S3 bucket you have to replace with your S3 bucket name. This specific name or this entire path you have to replace. My S3 bucket name is this YT 3-tier project. So you have to replace that, then only it works. If you are trying to copy from my S3 bucket, if you are simply giving this command as it is, it won't work. Okay, so you have to place it in your machine, your S3 bucket with your role, you have to get the data. So now I ran that command and data came here, it's under app tier. Let's go inside that app tier. Okay, So now we are inside that app tier and we have to install the missing packages. For that, simply you give npm install. Run npm install. So the installation, the package is also completed. Now we are going to start this index.js. So this give ls, you see here, this index.js is here, right? It is already copied and our dbconfig.js is here. Okay, so make sure that dbconfig.js has appropriate values. Okay, otherwise it won't work. Okay, so now we have to start this index.js. Alright, it got started and ID is 0. So if you want to verify PM2 status, you can verify. So if you want to stop it, you can use PM2 stop 0, PM2. If you run multiple, you can even give that also here. So now you can verify. You can use this PM2 list or PM2 status. Both give same output. And also if you want to verify logs, you can observe the logs, PM2 logs. If you are facing any error, that will display here. So if your output is this, I told you, right, your security group should open with port number 4000. Primarily, whatever the instance you have launched, that instance should be open with port number 400. The reason my application is running on port number 4000 only. The application currently I am running here. Okay, so this application, this index.js is running in by using 4000. You can even observe that by giving this cat command, you can verify. You see here, it is using port number 4000. Alright, so now that part is completed. You can make it as a startup service. So after reboot also it should start automatically. It got startup. So then you can save this configuration. So with this, almost all configuration part completed at app tier, application tier. Now whenever you are giving this command, when you are simply giving /health, so it should return with this is the health check page. That should deliver as a response. Paste, click on enter. You see here I am getting appropriate response. So we are good with this application instance configuration. Okay, the application configuration part is done. So then next what we need to do? So we have to create internal load balancer. Okay, so I will explain you how to use an auto scaling group feature with these EC2 instances. Okay, so but before that I am going to create a load balancer. For this I will apply auto scaling group in some time. So first go to this EC2, navigate to target groups, create a target group. Target type is instances. Target group name app internal application load balancer. So app is the tier, int stands for internal application load balancer, and this is running on port number 4000. My EC2 instance is going to communicate to this load balancer on port number 4000. I am going to open that here, and health check sometime back we run this health, right? So you can simply give this health as a health check path when you are creating this. So then click on next. Whatever the I have selected a different VPC, I assume. Yeah, that's the reason it is not shown any instances. Now I am selecting this app tier instance and port number again changed. Yeah, port number 4000. As I changed VPC, it got changed. Then click on next. Select it, include as pending below. Create target group. So now this target group got created. Let's create a load balancer. Load balancer. Create load balancer. Application load balancer. application internal load balancer. Internet facing? No, it's going to be internal. VPC, select the VPC. Subnets, you have to choose application subnets only. Select app1 subnet as well as app2 subnet. Security group, we created one for internal application load balancer. I am selecting it. Whatever the traffic coming on 80, I am forwarding it to a target group. Then scroll down, create load balancer. Now application load balancer created. So till here it's completed. Where is that? Yeah. So I am always referring to this diagram. So till here this load balancer, this instance got created, this database got created, communication is there. Now I have created an application load balancer. This is internal load balancer. I am going to add this EC2 instance to this load balancer. So technically till here it is completed. Okay, so these are all running in private subnets only till now. So let's create web tier now. So I'm going to launch another EC2 instance for web tier, and almost the installation process is going to be similar, but there I'm going to install Nginx. This is web tier. So this part is similar. I'm going to install NVM, that node version manager. So then I'm going to copy the data from my S3 bucket to this web tier. Then I'm going to install Nginx. Then I'm going to give permissions on Nginx data. Right, so that we have to perform from web tier setup. So is this load balancer provision? It will take some time. Let's go to instances and let's launch instance. Okay, let's name it as a web tier instance. Right, I'm going to take Amazon Linux 2 AMI, T2 micro. I'm going to choose an existing key pair and I'm selecting our VPC, but this time we have to choose public subnet. Why? Because this is web tier resources, right? So I'm going to launch it in public subnet even as per this diagram. Right, observe here our web server is in public subnet, and if you want to test direct output from this EC2 instance, you can use this public IP address as well. I'm using our existing security group, so that is web SG. So then 8 GB is fine, and make sure you attach appropriate role, YT 3 tier project role, then scroll down, then launch instance. Okay, by this time our, this is web, it's in pending state. By this time our internal load balancer creation should be complete, and here you can observe this is a DNS name. So what you need to do is you have to edit this. Where is that file? Okay, so here we have this nginx.conf file, right? You open it with your favorite editor, and this specific part you replace with the new internal load balancer. See why we are using this internal load balancer? If you observe this diagram, see we have multiple public instances that is going to send a request to app. So sometimes this instance may be healthy, sometimes it may be unhealthy. So instead of directly routing to individual EC2 instances, so I am using a load balancer. So my web server send traffic to this load balancer. Load balancer continuously perform health checks here. If the instance is healthy, then only it will process. Otherwise, it won't send the data. That is the reason I am going to edit this Nginx configuration and I am going to use this. So let me upload this file to our S3 bucket. So the nginx.conf need to be uploaded to our S3 bucket. Oops, it's not copied yet. So then upload. So this we are going to copy to our web server when appropriate time comes. Alright, this web EC2 instance is up and running. Let's get connected to it. See, the next parts, the installation parts, right? So installing this NVM and all these things, it's going to be pretty similar. So let's connect it to this instance first. So make sure you attach appropriate role, otherwise the session manager won't work. Click on connect. Sudo -su EC2-user. I'm working as EC2-user here. Let me go inside the home directory of this cd home directory of EC2-user. Alright, so now let's run this similar commands at WebTire. So the same, we are going to install NVM. So you can copy multiple commands at a time and you can paste it here. So NVM 16 installation completed and we are using it. So these all commands executed. So now, so you can go to home directory of EC2-user. So then you can copy the content. So whatever the one we have copied here in this S3 bucket, right? So you can simply use this copy S3 URI and you can copy to this, so you have to get this WebTire data to this EC2 instance. So currently I have nothing here. So let's copy this command. And you have to replace it with appropriate S3 bucket. This is the S3 bucket URL and copy this, paste it here. So now the entire content from our S3 bucket is copied here to WebTire. Let's go inside that WebTire. Go inside that WebTire and run this npm install and npm run build. So this is going to take some time. Okay, I have installed npm run build command also. Okay, so now let's install nginx within this machine. So we are using Amazon Linux Extras repository. Okay, so now, so basically whenever you install this nginx, right, you are going to get a regular configuration file. So but we have to replace that regular configuration file with our own nginx configuration file. This is the one, nginx.conf. It's a regular configuration file, but I did some modification to this regular configuration file. I have added HTTP to HTTPS redirection kind of things. So for that, what we are doing, first we are removing the file we have here. We have nginx.conf file here, right? We have removed that here. And then what we are going to do, whatever this nginx.conf file we have, right? So we have to download that to current location. For that, S3 cp, then the source path, then space dot. It should be AWS space S3, not just S3. So what you can do, you can simply use this command and you can replace with your bucket. You just replace this with your bucket name and you can run this command. So now permission denied. Why? Because we are working as a EC2-user. Let's add sudo works Yeah, it got copied here. So nginx.conf is now here. So once it is copied, you can restart the service. We are almost ending to. Okay, one small point to remember here. If you don't have SSL certificate or domain name, okay, so you no need to use this existing nginx.conf file. So when you clone this repository, you will get this nginx hyphen without SSL. Okay, you copy this, you replace this. So whenever at this particular step, whenever you are doing this implementation steps, so here we are removing this nginx.conf and we are copying this one, right? nginx.conf. So make sure you use this specific file content. So file name should be nginx.conf only. So but content, so please copy from here and replace with this nginx.conf. So or once you clone this to your local, right? If you don't have SSL certificate, if you don't want to go with Amazon Certificate Manager, so just delete all the content from this nginx.conf and go to this file and replace the content here, so that directly with load balancer DNS name also you can get output. So please bear that in mind. The process now, modify permissions. Modify permissions. So I'm giving read write execute for current user and read write permission for other user, and we are making this nginx service as a logon. Even after restart also the service should start automatically. So the initial or basic configuration part is now completed. Now, okay, if you want to test this output by using this instance public IP address, you can test it. But if you remember, whatever the security group we attach to this instance, we have opened for only VPC and we have piped to, like, only load balancer security group we created. So if you simply copy this and if you enter this here, it won't work. So what you need to do is open the security group, at least for temporary purpose, open port number 80, HTTP, open for anywhere. So now if you go here, if you give a refresh, you should get this page. Okay, so now if you click on this left pane, you see this home, this is DB demo. You remember, from connecting to database from application server and entering a sample entry, it is displaying here. Now we can start entering information. For example, I want to give 111, so the description, it is for grocery. So then add, it got added here. So I have another amount, like I spent 200 rupees for coffee, then click on add. So these all information actually stores in backend database. If I click on delete, all the entries are going to delete. If I just click on delete, all the entries we have here is going to delete. Okay, so that is what, this web page and everything is delivered via nginx. Okay, and connecting to this DB and entering information and adding this information or deleting this information, it is this application server acting as an intermediate thing between the database and this web server. Okay, that's a responsibility of application server, the logic, right? It's when I click on add, so the logic is processed by application server, it is storing into backend database. When I go to this home, it is showing this image. When I go to DB demo, it is showing this all database information we already have. Who is fetching this data? Application server is fetching, web server is displaying. So it is a perfect 3-tier architecture. Again, are we going to deliver our application by using such type of public IP addresses? 100% no. So what we will do, we obviously going to deal these things with multiple EC2 instances, and also we definitely need a load balancer. That load balancer should be internet facing one. So let me create a load balancer now. Go to load balancers. First create a target group first. Create target group. Target type as an instance. Target group name WebTG. Target port is 80 only. Then selecting our VPC. Health check you can go with slash. Then click on next. And select web tier instance. Then include as pending below. Create target group. Now create a load balancer. This time create it as a internet facing. Create load balancer, application load balancer. Okay, then click on create load balancer name, external web application load balancer, internet facing, networking map. I'm selecting 3-tier project and I'm selecting our public subnets. That's important. Okay, I'm selecting 2 public subnets, public 1, public 2 here. Security group, select web ALG, ALBSG. Port number 80, whatever the traffic coming, I'm sending it to web TG. Then create load balancer. Okay, so now the load balancer is going to create, we can access the same output by using our load balancer DNS name also. But again, see, we really don't use or share this load balancer DNS names with end customers. Okay, so what we generally do, we will depend on Route 53. So first go to Route 53. So we have playlist available in our channel. You can go through that. So whatever the so go to this Route 53. Now create a record. Create a record with alias and select this as a application load balancer. It's in Mumbai region. Choose the load balancer we are creating. Make sure you select external load balancer, not internal one. Then create record. So now instead of load balancer DNS name, what I can do, I can use this domain name. But immediately you might get a doubt. Okay, so we can access, but only HTTP protocol works, right? So how we can redirect HTTP protocol to HTTPS protocol automatically? So what exactly this means, we will test it in a minute. Okay, so this load balancer is provisioning. Once it is ready, we will test it. Alright, so this external load balancer is active. So now we can access same website by using this load balancer. Whether it's picking HTTPS, that's the reason it's not working. When we are okay, so it's redirecting automatically. That's the logic I have implemented in that the configuration file. So manually, if you are giving HTTP protocol also, observe here, if you are simply giving HTTP also, it automatically redirects to HTTPS. So to fix this error, what we need to do, so we have to generate an ACM certificate, we have to attach it here. But instead of load balancer, what you can do, you can use this learn-aws.co.in with HTTP protocol. It should work, but again, this is also redirecting. So because of the configuration, so how we can fix this issue? Okay, for that, go to ACM service, certificate manager service, click on request a public certificate. What is the domain name? Fully qualified domain name. My fully qualified domain name is learn-aws.co.in. How you are going to prove ownership on this domain? DNS validation. Scroll down, request. So now a certificate request got created, but it is pending validation. So what we have to do is, we have to create record in Route 53. Just you click here, create record. Immediately one record will create in Route 53 and this status will change to issued. Currently it is pending validation, right? So it won't take much time, just a minute or two it will take. So it is issued. So we have ACM certificate. Take that ACM certificate, add it load balancer level. Okay, so now this is external web ALB, add listener, HTTPS protocol, that is 443, and scroll down to security policy, get a certificate from ACM, select the certificate here, then scroll down, click on add. Okay, select a target group. We have to select, I'm selecting same target group, then click on add. So now automatically, so this 443 also added. If you don't open 443 at your security group level, you will get an error, not reachable kind of error. Now we are good with end-to-end part. So you can go here, you can access with your domain name. See, observe here when I am giving learnaws.co.in, this web page is coming. So even, okay, let me close this now. Let me take a new incognito window. Just observe here, I am giving http://learnaws.co.in. I am not giving HTTPS protocol, I am just giving HTTP, click on enter. You see, automatically the HTTP request also redirected to HTTPS and it is delivering the web page. We can go to this URL db demo and we can start entering 1 2 3 2 3 4, then click on add. You see here information is adding 3 4 5 Anu added, 4 5 6 Ara added. So basically this all information going to backend database and it is storing there. Okay, so this is how exactly we can add HTTPS protocol with ACM to our regular application. Now to all your end customer, you no need to open this web server directly. You can open traffic via this external or internet facing load balancer. So apart from this external or internet facing load balancer, you no need to open any traffic to anyone. Okay, so you can deliver your application securely. This is the end-to-end process. Now we still have an option. If you observe this diagram, right, we can add auto scaling group for this EC2 instances. We can add one auto scaling group for this private subnet instances, another auto scaling group for this public subnet EC2 instances. So let's take one at a time. So same thing you can apply for another as well. So let's take private subnet first. So first, if you want to create an auto scaling group, what you need to do first, you have to take that instance and you have to create a golden AMI. So then we will use that golden AMI and we can create a auto scaling group. So select this EC2 instance, actions, image and template, create image. So give a name, app tier golden AMI. App tier resources is the name I have given, then create image. If you want to implement this auto scaling group for your web tier also, better to create one AMI for your web tier also. Okay, so take this instance, image and template, create image, web tier golden AMI. I'm giving same as a description, then create image. Alright, so now, so I personally recommend once you test end to end, then only you implement this auto scaling group. Okay, so if you implement half and if you identified mistake later, it's a bit difficult. So once your application is fully working, I have tested my application is fully working with all features. So then I started configuring this auto scaling feature. So first create a golden AMI. My golden AMIs are creating. So then what I can do, I can create a launch template. So I will keep this web tier aside. I'm going to take this app tier only. So go to launch template. Okay, this one I created for a different project. that is also in works. You will get that video also soon. So go to this launch templates, create launch template. Now what is the launch template name you want to give? App launch template. So description version 1, and we are going to use this with auto scaling group. I'm selecting that here. And AMI, we have to choose the AMI we created, that is nothing but app tire golden AMI. Why? Because we are creating launch template for app tire. So then instant type you can include, or later you can include. I'm selecting T2 micro. Key pair don't include, I'm going with Linux KP. Subnet don't include. Subnet don't include. We can include this when we creating our auto scaling group. So I'm using this app security group. Storage no need to select. Then role, go to advanced details, select the instance role. So that is nothing but YT 3-tier project. Then create launch template. Okay, our launch template also ready. Oh, then our load balancer also we already have. Then go to auto scaling group and create an auto scaling group. Create auto scaling group. This is for app ASG, app tire ASG. Launch template, the one we created, app launch template. Click on next. Network, I'm going to choose appropriate VPC. Availability zone, you have to select app availability zone. As I told you, this auto scaling group I'm creating for application tier. So I have to select application tier security group subnets only. So app 1 and app 2 selected here. Then click on next. Now no load balancer. No, we already have a load balancer. I'm using that existing load balancer. Attached to an existing load balancer. Select your internal load balancer. Why? Because this is app layer, app internal load balancer. Then leave everything to default. Click on next. What is the desired capacity? I need 2 EC2 instances always. Minimum 2, maximum also 2. So always this auto scaling group maintains 2 EC2 instances for your application. So select minimum desired 2, maximum also 2. So 2, like if you want to configure this count based on the CPU usage, CPU load, also you can configure. So then click on next. Notification, you want to get any notification, click on next. Tags, you can give a name tag, app tire instances, click on next. Scroll down, create auto scaling group. Now this app tire auto scaling group is going to create multiple app tire EC2 instances. You see here we already have one app tire instance, another one is creating. You observe here, this I have not launched manually, another one is creating. So to creating, this is going to delete. So the newly created one is going to add to this load balancer automatically. So currently how many targets we have in this internal one? So currently we have only one. So now 2 added, this older one is going to deregister. We will always have 2 instances for this application internal load balancer. Similar way, if you want to implement this auto scaling group for your web tier also you can implement. So for that what we need to do, first we have to create a golden AMI of that web tier instance. Then create a launch template, create launch template, web tier auto scaling group. I'm giving that as a description. Provide guidelines. I'm going to select the AMI we created for web tier golden AMI. Instance I'm going to take T2 micro. Key pair also I'm going to take. Subnet don't include here. It won't allow you to select multiple. Okay, here if you are selecting. So select web SG also. and make sure you select appropriate role if you want to use SSM to get connect. Otherwise you can even ignore that as well. Okay, so YT3 tire, create launch template. Now launch template got created, so you are good to create auto scaling group for this web tire as well. So go to auto scaling group, create auto scaling group, web tier auto scaling group. Select the launch template as a web tier ASG. Click on next. Network, select your VPC, and subnets you have to choose public subnets here. Why? Because it is web tier, right? So select public 1 as well as public 2. Public 1 and public 2 here. Sorry. Then click on next. No load balancer. We have a load balancer, that is WebTG. I'm selecting that load balancer. Then click on next. Decide capacity 2, minimum 2, maximum 2. So always my application runs with 2 instances. Due to any issue, if any instance is down, auto scaling group will create another instance automatically. It add to the load balancer automatically. Okay, so now this app tier high availability is already configured. So to verify that, you go to target group of this app tier. We have 2 EC2 instances. Obviously one is going to deregister soon, that we can even find under this app tier here under activities and all. So one will select. Okay, so now go to instances, web tier also creating multiple here. Okay, I think I have not given the name while creating this auto scaling group for this web tier. We can add any tags here after launching. Yeah, I'm just adding a name tag, web tier instance update. All right, so now when something happens, so currently observe here total 6 we have. So even if you delete 2 app tier instances, you will get one more. So to test auto scaling, you just terminate some EC2 instances. So even I'm terminating some web instances also. I selected 2 web instances. I'm terminating it. So technically, how many instances we have currently? Only 2. One is app tier, second one is web tier. Okay, so this auto scaling group immediately detects, okay, what is the desired capacity, how many instances we actually have here. So if there is any difference between this, AWS automatically configure, launch, and it make that instance available for our workload. Okay, that is going to be a continuous process. Always this auto scaling group help us to maintain our instance with desired count. Okay, so is anything happening to our application? You can test it. Learn aws.co.in. You can test it. So yeah, you see here it's still working. Okay, so why? Because we have one healthy host, right? So that healthy host is going to take all the load. We can go here, we can take DB. So right, 234 ASD, I have added that here. So the functionality is not disturbed because of auto scaling group only, and only 2 in running state. If you observe, 3 came to running state. So the reason, auto scaling group. If you wait for some more time, one more will come here. Okay, so that is all about this AWS 3-tier architecture with high availability as well as fault tolerant options. Okay, so one small thing before closing this video. See, if you want to implement tight security across all these resources, we can configure security groups. So far whatever the security groups we have created for all these resources, We open for entire VPC, right? For example, this is our database. For this database, we have created a security group, and this security group we have opened for entire VPC. Do we really need to open it for entire VPC? Not really required. So basically, this database should be available to only these group of EC2 instances. These EC2 instances. That too specifically application tier EC2 instances. So how we can do that? Instead of opening this database for entire VPC, these EC2 instances have app SG, right? So open 3306 on your database security group, and it open to, instead of entire VPC, you simply give app SG. So database will be available to only application tier resources, only application EC2 instances only. Okay, so that is one thing. Now this application EC2 instances should be available. So whatever the port number it is running, the port number 4000 and all, that should be available to only this internal load balancer. So we can take this application security group, we can open port number 4000, and we can give destination as a internal load balancer security group. Okay, so this application server security group, I can make it available for this internal load balancer. So, sorry, this application ones, we can make it available for this external ones. So this external one, I want to open it for everyone. So this is actually more secured. So let's start one by one. So I'm going to take my database tier security group. This is my database. This is my database security group. So this database should be available to my app EC2 instances. So edit inbound rule, add rule. I'm going to open MySQL, and here I'm giving custom and I'm typing SG, and I'm giving app SG. So app servers only. Okay, then save rules. So, and also you can even remove this entire VPC CIDR range. So now anything affected our application level, let's go here, go to DB demo, enter something 234 QQQ, then add. You see here, so the communication not breaked, but we have tightened the communication between our database and our application servers. Now again, let's go to our application tier EC2 instances. See, for both the EC2 instances, I have used same security group. So you can pick application security group. This is my application security group. So currently what I am doing, I am making it open for all the resources. But do this application port number 4000 should be really open for everyone? Not really required. Edit inbound rules, add rule. So give custom TCP, that is nothing but 4000, and give here security group of your internal load balancer. So you can even remove this, then save rules. So now this specific EC2 instances, this specific application tier EC2 instances can connect to this load balancer. Okay, so now what about web tier? So you can take web tier, you can take web tier resource. Let me give a refresh. Yeah, web tier resources here. Take that web tier security group. Again, this also we have opened for multiple resources, right? We even open it for everyone for a temporary testing purpose. So what you can do, you can simply open HTTP, and here give security group of your web application load balancer, then save rules. So now let's go and test this application functionality. Let's verify anything break. So go to DB, right? Try something. I'm giving 237 Avinash, then add. You see here, nothing broken. So our application is working as it is. Now, what is the advantage with this process? See, the advantage is if anyone try to connect to my app server, or if anyone directly try to access this app server on port number 4000, will it accept? No. If anyone directly try to connect to this database, so we may have another application running in same VPC, that another application EC2 instance also may be in same VPC, but still if this another EC2 instance try to connect to this database, will it work? It won't work. So we have added more secured connectivities across all these resources. Okay, and once this golden AMI got created, you no longer required that NAT gateway also. You can even delete that NAT gateway. So that is what exactly this three-tier architecture is. And let's discuss the cleanup process. If you want to delete all these project related resources, so what are the things you need to delete? So first, delete your auto scaling group. See, if you simply go to this EC2 screen, okay, if you simply go to this EC2 screen and if you're selecting all this and if you're terminating, your auto scaling group will automatically create two more EC2 instances for app, two more instances for web. Okay, so as a first thing, go to your auto scaling group, delete these auto scaling groups. Okay, delete it to, you have to type. So once this got deleted, then go to your load balancer, select both the load balancers, delete the load balancer. So once load balancers got deleted, then go to target group, then delete the target groups. Both the target groups got deleted. So then go to AMIs. We have created a couple of AMIs, right? So there is no option to delete. You have to deregister this AMIs. Once deregistration completed, you have to delete the snapshots that created for that AMIs. So whenever you deregister the AMI, snapshots won't delete automatically. Go to actions, delete the snapshots now. I hope we have not created any volumes manually. So we are good with this volumes part, and you can observe here all instances got terminated. If any instance not terminated, please go and terminate that. Now come back to our database. So go to actions, delete the database. It's asking, do you really need a final snapshot? Not really required. I'm going to select I acknowledge that, then type delete me, then click on delete. Alright, database is deleting. So once this all deleted, if you really don't want, so you can even delete your S3 bucket also. This is our S3 bucket and our code, right? I'm going to I already have a copy of this code, so I can delete this folder, and once I delete everything, or we can simply do this, go to these buckets, first make it empty, you have to type it permanently delete. So once all data deleted from this bucket, you click on delete and enter the bucket name to delete that specific S3 bucket. Also, we have created ACM certificate. Go to certificate manager, delete that certificate if you already purchased one certificate. Right, if you already purchase a domain name and if you already purchase. So then go to route 53 and delete the entry we created for this. So basically a record, right, we created. So I'm deleting that a record also. we created, and once all these EC2 instances and everything got deleted, then we can delete this VPC. So can we simply go and delete this VPC? No, you first have to delete this network NAT gateway. So go to NAT gateway screen, delete the NAT gateway. Observe here, see this deletion process, how much time it is taking. So yeah, once this NAT gateway got deleted, so then you can just observe any additional resource are available. So then you can simply go and delete this entire VPC. I will verify whether any network interface is available here. There is only one, that is for NAT gateway. And also one more important thing. So whatever the NAT gateway we created, right? For that NAT gateway, we will get one elastic IP address. So that elastic IP address won't delete automatically whenever you delete your VPC or NAT gateway. So you have to manually release this elastic IP address. Okay, otherwise that elastic IP address also will cost us. So select 3-tier VPC, delete. Now it's allowing us to delete, but remember all the security groups also going to delete. Then click on delete. We should not have any running resources if you want to delete this VPC. I have deleted this VPC as well. Okay, and only one final thing, that is elastic IP address. Select it, actions, release elastic IP address. Alright, this elastic IP address is now released. So this is how exactly we can clean up the resources we created for this 3-tier architecture project. If you spend enough time, if you complete this project, automatically you are going to get confidence on this AWS architecture, how things are going to work. I personally recommend you to go through this video multiple times. Don't stop if you don't understand this topic. See, whenever you observe for the first time, definitely it looks bit complex. If you go through again and again, if you practice again and again, you can definitely achieve similar kind of output. And all the required resources like a load balancer creation, Route 53 creation, right, ACM creation, these all videos available in our YouTube channel. You can take some time and you can go through that videos so that you can be master in that also. And also don't forget to go through the project playlist. And if you're also looking for DevOps kind of services, we have Git series, we have Ansible series, we have Docker series. I personally recommend you to go through that masterclass series also to gain more knowledge on this Amazon Web Services. I personally thank you for your time here, and if you found this video helpful, don't forget to subscribe and don't forget to share with someone who is really working and learning this AWS and who is actively doing this job search. It might definitely help them. So see you again in next video. Thank you.